everyone. Welcome to episode number 14. Yes, this is number 14 of the Amiga 68000 programming and development course, which is based on the book by Fabio Ciucci, which I thank personally for letting me stream his book. The book was written in Italian, but to be honest, you have my explanation in English, and also the most important is that you get the code and start using the code, and that you understand the code. But as I said, you should not have an issue because I'm explaining that, so you should be able to start coding. The aim of this stream is to get more people to code on the Amiga. So basically, what I was saying is last week we started how to write how to write text to the screen, and we just explained the theory behind it. Okay, we didn't actually we haven't done any code yet, except Fabio introduced us to a new routine. Okay, which I explained, but I'm going to explain again because the book. Okay, so this is the routine, and then he grabs it bit by bit, okay, and explains it again. So I am going to stay on the routine because you cannot understand Italian, or at least some of you won't. And so you'll see the routine constantly on the screen, and I will be explaining it line by line or block by block what it does. Okay, so the first part, line 2, we take a pointer to our text. Okay, what we want to write to the screen, okay, is whatever text we want to write. Let's say we want to write the word, the famous word, bow, people bow, phase 101. Then it has to take the first letter, which is the letter P, and print it to the screen. No, so we initialize the first pointer, which is the register 80, and we point it to our text, okay, where we are going to read the first character. Then we have to point where we want to print the character, okay, because one is from where we are getting it, our ASCII value, and the other one is the font. Now the font can be bigger, remember the font can be 8 by 8, 16 by 16, 32 by 32, whatever. So that letter that we're going to print, okay, we need to tell it where, and we need a blank paper, which is our screen. So we have our bit plane, okay, so that is line 3, where we're going to print the letter, basically the first letter. Then if you recall, and I'm going to discuss lines 4 to 6, okay, if you recall, ASCII, the ASCII character set, of course starts from 0 to 255, sorry, but space, okay, the space, spazio, okay, the space character starts from number 32, which is 20 hex. So our font, okay, starts from character from number 32, okay, which is 20 hex, as I said. So everything that is below, we don't have it in our font, okay, it's empty, there's nothing. So anything else, after the space there are symbols, then there are the numbers, and then there are the letters. First there are the capital letters, and then there are the small letters, and then some more symbols. So what we do is we take the character that we got from our text, which is, let's say it's the character number, the character A, no? If it's A, okay, let me see if I can help you a bit here. Let me see before I change. it's here. Yeah, it is here. Oh, come on. There you go. Okay, so we have our ASCII, okay, and as you can see, it starts from 0, but space is 32, okay, so it's 20 hex. You see, this is hex, and this is the space, and this is the character. What I was saying, we take the space, okay, remember space starts at 20, so if we have the letter A, you see it's 65, okay, the letter A is 65. So, or 41 hex, okay? So we remove 20 hex from it and we get 21. Now our font is an 8 by 8 font. So 8 pixels by 8 pixels, okay? So we multiply the offset, which is 21, okay, by 8. So basically, we deduct from 41 hex 20, so we end up with 21. 21 times 8, we get how far pixels we need to go down from the font. Now, so if we have the base font, our sheet where the font starts, okay, whatever that address is, we need to add the distance further down of where the font starts, the letter starts. So basically, that is what lines 4 to 6 do, okay? Then, as I explained, we need to multiply it by 8, which is line 10, okay? So if we had 21 hex, we multiply that by 8, and we get the offset from the base of the font where our font sheet is. Let's say this in memory, and then as you can see, we add the offset that we got to the we move it to A2 first of all, and then we add where the font is with the base, the font base. This should have been called font base, to be honest, but he called it font. It's where it's loaded, and we add that to A2, okay? Once we have done that, once we have where our letter is, the letter A in this case, okay, we move what we have in A2, okay, the first byte that we have in A2 to A3, okay, which is the screen. And then we move again what we have. Remember, it's doing an increment A2, so it's going to read the next byte. So we move what's in A2 to there is a 40 and then A3, so to what is the base plus 40. Remember, it needs to go one line down on the screen. Remember, each screen has got 40 bytes, so we need to add 40 to that to the A3 address, so we can print it. So if a font is as I said, it's 8 by 8, 8 pixels by 8 pixels, but you know, it's 1 byte. If it's 8 pixels, it's 1 byte horizontally. So to get to the next byte, which is below it, we need to sorry, not to get to print the next byte, which is below it, okay, we need to add 40. We need to jump a line, basically jump a raster line, and print the next byte, and we continue to do that by 8 times. Now here where there is, you know, A2 plus and then bracket A3, okay, he could have done, I mean, I prefer doing it this way, which is more logical. I mean, it's just a calculation that the assembler has to do. I would have done 40 times 0, 40 times 1, the second line, you know, line 17, I would have done 40 times 1, which is 40, still 40, and 40 times 0 is 0, and then continue doing as what he said, which makes it more visible, which makes it more intuitive, let's say, when you are looking at the code. That is all. So that's how we print our font, which is a bitmap font or bitplane font. I don't want to use the word bitmap because it sounds more complex, while bitplane, you know, it's just zeros and ones. I should have changed to the book, which I didn't do. Sorry for that while I was explaining it. So I'm just going to repeat this part. I didn't change to the book, and it's my fault. It's not because I just continue talking. I know it so much by heart now that I was talking and I then didn't realize that I didn't change the screen. So it's like having a slide and you didn't change the slide and you continue talking. So I do apologize. So we did the multiplication I explained, we added it to the font base, and then here is where we print each byte, which that forms our font. Okay, the book now takes what I did, what I just explained, and explain it bit by bit. So if you can see, it's a copy of our code, but explains it in Italian. You can see it's the same code, nothing changed. He's just explaining it in Italian, which I just explained it in English. Okay, so nothing to worry about there, and it continues till down here. I'm just going to click on this one and see if there is something in my notes that I might have skipped, but not really. He's explaining the same thing as I said, the character A, which is 41 hex, and then how you do a multiplication. You see, you subtract 20, you end up with result 21, and then you multiply by 8, which is this part, and then you add this to the font base, and then how you move it. Now, because we're doing the plus 40, okay, this is how it is printed. This is first of all how the font is stored on our sheet, you know, where we have our font base, line by line on top of each other. Okay, remember the sheet is 8 pixels wide and God knows how many pixels down, because each font is 8 pixels high. If we don't do the plus 40, this plus 40, okay, here, okay, and we don't skip a line, they get printed one next to each other. That is what happens. This is that's why we have to do that, basically. Well, also it makes sense. Now, if we need to print something below of what we have, we need to skip 40 bytes now to be there. He continues to explain what I said about you know, adding the 40, but at the end here he explains, okay, instead of when we have a high-res screen, okay, so now it's not anymore 40 bytes wide the screen, but 80 bytes wide. It's 640, not 320 pixels. Then we need to add 80 and not 40. So this part of the routine changes to 80. Okay, so if we need to use it for high res instead of low res, this is what we do. Okay, and the code remains the same. Okay, and he's mentioning that it is a high res screen here, and that you have to have 80 bytes. I mean, numbers you can all read, even though it's in Italian. I forgot to enable the option to scroll. Yeah. So that's better. So we arrived to our first example. Okay, so let's jump to the Amiga. And let's start our assembler. I forgot to start the assembler. RamJam and Sergeant aware. And we are in chapter 6, number 1. Before I continue, I want to show you. So chapter 6 examples starts from this one, and there are 2 pages of this. Okay, so there are quite a lot of examples to go through and for me to explain. We will not finish this chapter today. I can tell you that because I didn't finish it yesterday. We will finish it probably next week, but there's a lot of material to cover. I think it's one of the longest chapters this chapter, remember, is called text, so you display text on the screen. And also he continues where he left with chapter 5 about horizontal scroll. So basically now he goes in more advanced detail of how to do horizontal scroll, because last time we just saw the bit shifting but not real proper horizontal scroll. We saw vertical scroll and proper one, but not horizontal one. So we're going to see that in this chapter. The chapter after this one is sprites. So we will be talking about sprites once we finish this. Okay, so this example, okay, is the book's example. I actually added some more examples. So we going to read 6, not A1, sorry, 6A. Okay, this is exactly what's in the book. Okay, we assembled it and we run it. You can see, okay, in the top right hand corner we have our letter, okay, the letter A. Okay, so this is a copy of the example that's in the book, in the not in the exercises book but in the other book. Remember, there are 2 books, and I'm going to jump to the other book now. Okay, given that I get the book, because now you're getting the book and I don't get the book. So this is what the code looks like. Now, as always, because it's the first example in this chapter, I go through the whole code, but then I stop repeating the code, because all we are interested is in this part, which is always magenta, where he jumps to a routine which we will cover each time as we go along in the book. The first part is killing the OS and getting the copper where it is. Okay, then we set our bitplane pointers. We store, we actually store the copper, the system copper, copper list here. We initialize our copper list and we make sure that our Amiga is compatible with AGA. Okay, so that the Amiga, whoever has got an Amiga 1200 and Amiga 4000, it will work. Okay, then we have our routine, which I will discuss. Then we have waiting for mouse, and then we restore the OS back to where it was, and we jump back to our assembler, basically, in this case. Here, okay, here, this line, you see there's only one letter, okay, which is the letter A. It's the only text we're going to write, okay, on the screen. And note there's even, because remember, the 68,000, the instructions needs to be always on an even address. And basically, we need to do that. Even if we don't do it, we get a guru. Actually, it will not assemble the code, as you will see in a minute, because I will show it to you that it will not assemble. Now we have the routine that we did in the book. Okay, it's a copy exactly of what we did. I'm just going to do it like this way, so you can see nothing changes. It's a perfect copy of it. So this is the routine that he's calling up here to print the letter A. Okay, so nothing changes. Of course, the copy list, this is the pointers. We're setting up the pointers for the sprite pointers. We are setting up our bitplane, you know, where we are going to write to the screen. Okay, and this is the font that we are loading. Remember the font, I will show it to you if you forgot that it is one letter on top of each other. And then this is the part where we use section, okay, to not waste time on the section BSS, basically, not to waste time, not to waste space on the floppy, and tell it when this program loads, allocate a block of memory of 40 by 256, which is our bit plane, 1-bit plane. So basically, where we are allocating our bit plane to so that we can write our text. Okay, so that's what it does. Instead of having when we use this section command, this assembler directive, we are telling it when this program loads, allocate this block of memory. We have our code, and then we are going to start doing the exercises. So this is modification number 1. But before this one, I think I made a modification of my own, which is I'm going to show you. I think it's the same thing that you are used to. Let's go back to the Amiga first. So today, this is what the program did, his program, the program of Fabio. And we're going to read the first one, where I kept the same program and I believe changed the color to make it more visible. That's all I did. All I did is adding the color, but so that I show you that the next examples are so what he asked in the first example is to do some remarks in front of some of the code, and because of what we did, we only printed 4 pixel lines, okay, of our font instead of 8. So I'm going to show you that of what we did. Need to change to the book, and I need to change to the book. And you see, he asked to do a remark, and because of that, we only printed the first 4 lines of the letter. This is to show what he meant by adding these 40. Okay, remember the width, screen width is 40 bytes. So to print each character, not each character, each byte that forms the character on top of each other, you need to add 40 to each line, basically. Modifier number 2 is he asked to remove the even after define constant byte. Now, for those that are experts, you know that you cannot do that because instructions of the 68,000 need to be on an even address. So this makes a guru, but see what actually happens, okay? And let's see those that really know that this can provide a guru, what the assembler does. Because I don't think at my time the assembler was not able to do what it does now. So yeah, it's a nice feature of the assembler. So let's read it. Okay, and I'm going to show you that we removed, where is it, the letter A, it's here. Yeah, we removed the even, okay, from under it. See what happens. We are going to assemble it, okay? Ready? Go. The assembler will not assemble the code. It knows you are going to generate a guru. I can tell you this feature did not exist in the earlier versions of ASM Pro or ASM 1. So it's telling you that you cannot assemble the code. That's part 2. I don't know if Vesim is able to detect this, actually. It would be interesting to know. Because this was an addition that they added afterwards. So this came in 2012, I think, the addition, or later. So number 3, let's see what he says for number 3. So here, okay, modification number 3. We are going to uh, move. Uh, we are going to move where we print our line. Okay. Now, actually, I did more than this. So, and actually, there is more than one also here. So, can you guess what happens if you add 40 times 120 to A3? Now remember, 40 is the width of our screen, and 120, we are multiplying that. So the first one is adding 40, okay? Sorry, multiplying 40 by 120. So that means to where our screen base is, okay, where we start, where our bit plane is, we are going to jump to 120 lines further down, because it's 40 times 120, so it is 120 lines further down. And then here we are going to jump the same 120 down, sorry, not this one, this one, okay, 120 lines down, but we're also going to add 20. Remember, it starts from 0, so we're going to position it in the middle of the screen. So I'm going to show, so the book is showing two things, okay, here. One is adding 40 times 20, and one is 40 times 20 and the 19, which is the middle of the screen. I think I went a bit more than this. I did a bit more than this, but yeah. So let's change to the Amiga, and you got the Amiga and I got the Amiga too. So 4, I believe, no, not 4, 5, assemble J, and this is the one I think yesterday, because I was showing, I think I saved over one of them. So I'm going to check if the next one does the same. Then this one should have not put this letter A in the middle of the screen. So that's what happens, and I'm going to show you the code, what he did. So you see, this is adding 120 lines. Okay, this is 120. Each line is 40 bytes, and then 19. Remember, there's a 0 is 20. So if it's our screen is 40 width, 20 is the middle of it, and it printed the character there. The rest is the same. I'm going to see. First of all, did I do 4? Yeah, I skipped 4. So 4 was without adding the 19, and as you can see, it is on line 20, but on the left hand side. So you can see it here. There is no character. So to move the letter A to the right, we add bytes here, basically. So if we add 10, okay, it moves 10 character to the right. I'm not going to do, because the assembler will try to save it. As I was saying, this is a way of, no, don't save. I changed. I click on the mouse wrongly, and that's what happens. Tools, RamJam. So we are in number 4. We did number 5, and we are going to do 6C now. I believe the book. Let me see the book. Book. I believe the book. Yeah, we have to do till C6, C2. Okay, so we have to do from where we are B to 6C2, because then the font will change actually. So yeah, okay, let's continue. So most of this time we're going to spend it on the Amiga today in the assembler. So 6C, let's see what it does. And our first screen full of text. Okay, there's a reason why it is divided, and you can see it's blue and black. Basically we have a copy list there. I added the last line. Okay, I just wanted to be funny. He wrote something in Italian about direction, and I do not want to offend Dante Alighieri, but I added the right direction in Space 101. It has to be. So as you can see, we have our font. You are seeing the whole font with our symbols. You can see, okay, here we have our numbers. Okay, here we have the symbols. Okay, and this font doesn't have any color in it. Okay, he's applying color to it by the copy list. Okay, so nothing changes in that sense. Also, we are using a different font, which I'm going to show you. Okay, so I forgot to show you actually. Let me remind you from the book. Okay, let me remind you from the book. That if we scroll up, just to remind you what we did last week. Okay, the font, okay, is stored like this on the Bitplane. Okay, on as a file. Okay, so it's an 8 pixels wide, and then God knows how many pixels this is long. Okay, that's how it is stored. Just to remind you why we're able to jump from here, which is our font base or font, to let's say letter A. Okay, which we do 21 hex, which is 33, right? And multiply by 8, and we arrive to the letter A, where we have our letter A stored in this sheet, if you want to call it sheet. But yeah, let's go back to the Amiga. Okay, so the code. So first of all, this is our text. Okay, this is our text. Now, before, okay, you are seeing just one letter on the screen. Okay, so I will jump to the book in a minute, but I just want you to note that all the text on the screen is this, and is defined as a constant byte. If you notice, to help us, he wrote the numbers, how width each text is. Okay, there's lots of waste in a way for those that know how to code, but remember, this is how to show you how to print text to the screen. So it's not about how to optimize right now. And he also, to help us, he also did the line numbers. Okay, and this is the one, this is the sentence that I added myself. Okay, and further down, which I will come back to this, you can see before we were using the normal font. Okay, and now we are using the metal font. Okay, to show you that you can have multiple fonts if you want to. There's nothing stopping you from having different fonts or more than one font. Now the colors, they are all here, the normal stuff done with the couple list. Okay, so you can see the color changing for let's see which part is this. This is, I think, the the line on top before the blue, where he is doing the magenta color, and here, yeah, and here is the one in green. So I can see this is a green color, but he's changing here, or shades of green, let's put it this way. So yeah, then further down we should see the split, and you can see the yellow and the blue. Why is it yellow and blue? Because I did it. I think in the book it's not yellow and blue. I think it's black. It's blue and white, I think. But yeah. Now, I'm not going to show you the routine here. I'm just going to, because it's easier to explain it in the book. So I'm just going to jump to the book. And I have to go to the book too. So we were doing, so we did all this, and we're doing 6B. Okay, there's a reason why I have darker magenta. Let's put it this way. Oh, no. I jumped too much. I should have not touched. I think it's this one. No. There you go. Okay, so it's the same routine, okay? Same routine, but with a slight difference. Why with a slight difference? The scroll is not working properly. Enable scrolling, yeah. Okay, so the part that is this color magenta, not the darker one, is the routine as we know it, with an addition, okay, because we are printing more than one character, okay, so we need to move one byte to print to the next one. Once we finish one character, okay, printing one character, we need to move to the next byte to print the next character. No, so basically so basically what we are doing here is telling it, okay, our screen is 40 bytes wide. Remember, we start from 0, so 40 minus 1, and we are using register D2, okay, I believe, or D0, or is D0, sorry, to as a loop to read the character, one line of characters, and print it to the screen. What he does further down, okay, you see the 0 is the loop. We're going to print one line. Actually, I think I showed you an example that comes later. This is 6B. I think I showed you 6C. Anyway, it prints one line of text, and to do that we add 1 byte to A3. Remember, A3 holds the address of where we are on the screen, so we need to move one position to be able to print the next character. Another thing, please note that we are using the CPU to print to the screen. Later on, you'll see you'll be able to print to the screen using the blitter. Okay, so right now we're printing a font using on the screen using the CPU. So bear with me for those that know that you can use the blitter. Okay, we're just following the book. So once we add one, we continue to loop. Okay, loop till we have printed a whole line. Okay, so now I'm going back to jump to the Amiga. Okay, you see, I told you I put the wrong example. Well, I said I jumped to the Amiga, but I didn't jump. Here at the top of the screen, you can see I am in lesson 6C. It should have been 6B. So let's do that because we skipped one. Actually, not one, quite a bit. And as you can see, we printed the first line. Okay, for those that have doubt of what's on the screen behind the not the logo but the text of what we display, okay, you can see, okay, it's the mighty Phase 101. Sorry, I'm having a laugh about this because when I was doing this chapter I said okay, I'm going to use Phase 101. Anyway, so we just printed a line of text to the screen, and using the same routine by adding a loop into it so that we can print one character next to the other. That is all. We continue always printing one line. We assemble it, and what happened here, I need to look at the book because it looks the same but actually it's not the same, or it shouldn't be the same. So let me look at the book. So that was 6B1. 6B1. I'm just looking at my notes because sometimes I'm faster looking through my notes. 6B1. So we are in 6B2. Oh, yeah, at least not from my side. Hound dog. Anyway, let's continue. So 6B2. So where is 6B1? Or maybe, because I'm starting to think, actually, I know what I did. It's the same one with a different font. That's an exercise that I saw. It's a different font, although you can hardly really notice it, but yeah, it's a different font. So nothing special there. Let's read the next one, B2. Okay, so we moved our line to the middle of the screen. How do you think we did this? Well, you saw how we moved the letter A. We just did 40 times 120, and we moved the whole line to the middle of the screen. Okay, nothing else, nothing special from that, and I'm going to show you that that's all that we did. see, line 58. Hold on. Yeah. Now I didn't switch. It's my fault. I was talking and didn't switch. It's not even myself I switched, okay? Yeah. My God. I'm on an automatic pilot today, I think. So line 58, as you can see, has got what I just said, 40 times 120. That's all. I believe the book, let me jump to the book. Well, you get the book before me. We're still doing 6B. So these are all my examples. Sorry guys, I thought they were part of the book. These are all examples that I edit myself. So yeah, so there isn't text in the book to explain. Let me continue. So this is one of my own extra additions, okay, where I edit and move the line to the middle of the screen. Okay. Here I just change the font. You can tell. So I'm using the metal font, and I believe the one before it was the normal font, because that's the font that we are normally using. Another font. So here I changed to not normal, or I think this is the normal now. Let me check. Yeah, now it's the normal. So I just changed to the normal back again. So nothing new there. As I said, some of these are me experimenting, but I tried not to mess with the code related to the book. J, and I believe this is the other font. So all I did is showing you a line each time with different font. Yeah. Again, metal, so it should have been. Ah, sorry, the default font is nice actually. Sorry, the default font is nice. The other two are extras. So sorry for that. I told you that is the normal font, but actually it's the nice font, which is the default that he uses in the examples. Okay. Okay, so we did 6B, and there is 6C. Now don't think that I added too many examples of mine. Actually, the book has got a lot, so I only added a few just to enhance and maybe help you understand what we are doing better. That's the aim of what I do. As if there's something that I did myself for my own thing, I will not be included in the book. But here is just to show slight changes. So we are in 6C, okay. And this is the one that I jumped earlier, and now I am back to it. So this time I will go to the book because there's actually documentation related to it. So let's see. Actually, no, forget it for now. 6C. There you go. So we have our usual code and then our routine. And this time, okay, he added something else. He added that we need, I forgot to mark the bottom part. We need also not just go on the X, so from 0 to 40 to 39, sorry, on the X to print a character, but we can also go on the Y. So he added this part, and we have to print 23 lines. Because of my modification, we are printing 25 lines, and I will show it to you that we are printing 25 lines. So before, the routine was still here till the decrement and branch, okay, but he added this part, okay, to this to the routine, where it does 40 times 7. So remember, it's times 8 actually, because there's the 0, but in terms of calculation it's 40 times 7. We add that to the A3, which is the address where we are printing on the screen, our screen, basically our paper where we are writing. We jump 8 raster lines, and then we print our next character, and that is why he has done basically that. This is, as you can see, he has 23 lines to print, but I added another line which is 25, and nothing else changes in the code of 6C. Of course, he has the examples, but we haven't arrived there yet. So let's jump to the Amiga. Okay, I'm going to show you my changes, and so the routine, you can see it's not 23, but it's 25. Okay, it's common sense. And what I added, line 25. Okay, there is nothing else that changed. The routine is what I said. Where is it? Yeah, that he added this part to say, in fact, in Italian, he still left, I mean, I still left it as 23, what he said. We're going to print 23 lines of text. He added this part to the routine that earlier he had added this part. Okay, so that's the first, let's say, inner loop, and now we have an outer loop. Okay, the inner loop does the X, and the outer loop does the Y. Okay, what I want to show is, which I explained, but I'm just going because now it makes more sense with this example, is that we have a LowRes screen. You see bit 15 is 0, so that means LowRes. Here we have the colors that are green. I will show it to you again, the screen. And here, this part is the magenta part, or whatever you see, or whatever you want to call it. So this is the greenish part, let's put it this way, okay, and this is the magenta part, okay, nothing else. So we let's say have finished from explaining this, the code here. We need to read 6C1, C2, sorry. And this time we have again a screen. He didn't use colors here. We have again a screen with sorry, I just need to laugh because I'm realizing what I did when I was writing my notes. He had prima riga, you know, first line, and I said phase 101 is first line. So yeah, but what he wants to show is that we have some characters which we change them into a smiley face. Okay, so the font in it, so he prints the font here, the symbols, and you can see the @ sign has got a smiley face. okay, instead of an @. So we are going to I'm going to show you the source, so you can see that where the smiley faces are the @. Okay, so the @ is being transformed into a smiley face. Okay, 6C to B, and this is where we had to stop. So doing this one, and then we need to jump back to the book. Now, this one, you can see that there is half of phase 101, you know, the letters phase, and half of uh, what we build can never be destroyed, which is our sentence. The reason being is that the font, okay, I'm going to show it to you, is made larger, but for laziness, I didn't complete it. Okay, actually, Fabio didn't complete it, and I didn't complete it after him. That's reality. So it's only half of the letter that there is, but and I'm going to show you the font. So that is why you see, if we take the letter A, let's find the letter A. There you go. You see the letter A, only half of it. I should have more define constant block, okay, and define the rest, the rest of it. But I didn't do it, and Fabio says the same thing. He was too lazy to do it, so he just did that. He basically, what he was doing is copying this line and creating another line, then copying this line, and then he just decided, okay, I'll cut it off, and basically that's it. So he just got fed up of doing what he was doing. But you got the gist. It's a font which is supposed to be 8 by 16, not 8 by 8. Okay, in the book, okay, he was more nicer in the book, the actual book now. We did 6C, 6C2. To B. So if we continue scrolling down, now you're going to see the font. Okay, and that's how the font is defined. He defined all the font like this. Okay, he didn't want to do it all, basically he got lazy. But yeah, and I left it also like he left it, so his wish is my command, in a way. So yeah, that's the whole 6C2. I forgot the number of the exercise. 6C something to B probably. Just going to continue because we will need to I need to scroll anyway down till I find the next exercise. So yeah. Somewhere here he says that he was lazy, but look, this is how it should be defined. He said he just did one. Okay, so I am in 60. So somewhere, there you go. That, just in case. So we jump back to the book. Okay, we did 6C2. and we jump back to the book. And now he starts talking about we can define our font ourselves, as you saw, by using zeros and ones. And he gives an example here. Okay, it's one bit plane, and that's basically it. He talks about having a higher res a font which is 8 by 16 here, or even higher, with 16 colors or 32 colors, whatever. We all seen fonts in demos, we know what it can do, and yeah, he's talking about that here. So we arrived to 6D. I thought he's going to mention something else, but I was wrong. So let's do 6D. Let's jump to the Amiga. And execute it. Okay. Now, this example, okay, we have two things happening. Okay, we have actually three things. We have our routine that is printing text to the screen. Okay, we have our image, which is low res, on the top part. Okay, you can see that that image is low res. Okay, and then guess what? We have a screen which is not low res but high res. That's an 80 column screen. Okay, 640. Okay, so that is why, okay, you see where Amiga is, the sentence continue, okay, in high res pixel 640 pixel de larghezza. It means we are on an 80 byte screen. Okay, and he continues to show the definition of the font further down and other things that on the screen I didn't write anything myself. So I'm going to go through the code and what happens here with 6D. Okay, it's quite easy to be honest. We jump to the book. Okay, and what you need to understand, so that's our print routine. It's the usual print routine, but we are on 80 column mode. So the 40 was replaced by 80, but still the same thing. And here it was 40 minus 1, now we have 80 minus 1, but still the same thing. And as you can see, the text is written in 40 column, but because we have an 80 column screen larghezza, okay, this part, okay, for those that do not understand Italian, is one word on our screen, on the Amiga screen. Okay, I can show you that quickly actually. We exited, so no, not really. I thought I had left it running. So what you need to know, okay, the first part when we initialize the screen, okay, notice as I said, bit 15, sorry, is 0. Okay, so we are in low res. Further down, you're going to see that we changed it to higher res. Okay, and because of that, we update the data fetch start and data fetch stop. Okay, to be the values that higher res needs to be. Okay, so this is the first thing that we need to do when we are having a high-res screen, because data fetch start and data fetch stop change. We will come later on to data fetch start and data fetch stop, because in horizontal scroll you need to play with these. But yeah, and you can see he's waiting for line 80, okay, where we split the screen. So we split the screen, and from time to time, we because I just read his sentence, Houndog sentence. So basically, we are splitting this screen to high res, changing the high res at line 80. Okay, nothing else. And you can see the font is the nice font. Okay, so we need to do 6E, I believe. So I explained that. So 6E. Okay, so actually, look, I did 6F. I highlighted it. That's the last one I did yesterday. So we do 6E. Okay, I don't know if there is 6D. I don't think I included any more examples. So 6D, there's nothing. 6E. And there you go. Actually, this is one of my favorite examples that he has in the book. This is such a cool thing what he did here. You think you have a 3D font, okay, with 4 colors. So you think that the font has got a, a depth, but actually, when I think how he did it, it's so clever, and I wish I knew that back then. So what he did is printed the first screen, okay, like imagine our blank paper, and you print our sentences to the screen normally, okay. Then the second screen shifted it by minus 80. Remember, this is a high-res screen, okay. And because he shifted it by minus 80, and he printed the same text and same screen, okay, same on the same bit plane, sorry, different bit plane, but same memory basically. He shifted the characters. If you see, I'm just going to show you. You see the white, okay, it's one raster line up. Actually, let me start again. This is as you see, what he did is, imagine, okay, there is only our plain paper, our screen, okay, with nothing on it, it's blank, okay, and we print all those sentences on our screen. And remember, this screen is a high-res screen, okay, so it's 80 characters width. Now when he printed that, okay, to the first bit plane, he said, okay, we're going to have another bit plane, but we are going to populate it with the same text and everything the same. So if you had to do a bit plane on top of the other, what will happen? You will see the same thing. I mean, the worst that can happen is the color changes, because when 2 colors are on top of each other, that means a different color on the Amiga, because that's what the bit plane is. But what he did is, instead of printing them on top of each other, he said, if I shift it by 80 bytes up, okay, I will create this depth. You can see that it has a line at the top, okay, maybe on the letter S it's more visible, okay, which is white, okay, so one line further up, okay, and because he did that, you can see there's also a line at the bottom, so there's always a line extra on top and a line extra at the bottom. The line extra is because we shifted the screen one up, or the bitplane, sorry, one up. Okay, so we see the white. Okay, and then because there's no other font, and the second bitplane is zeros, then it changes the color, and this creates the illusion of having a 3D font, or a font with some shades. Okay, but it's very clever. I'm going to show you what he did, and it is unbelievable for me. I really didn't know this trick. This is what he did. So it's the same bit plane. Okay, so the pointer points to the same bit plane. Okay, but minus 80. And so in the register where he points the so this is the same routine. This is our text. In the registers here, okay, so this is the first bit plane where he assigns where our bit plane is for the screen, and the second one, okay, he gives it the same address as this one, minus 80, which is what you see up here. Okay, what you see up here. You see, this is the initialization of the first. I mean, I didn't highlight this for intention, not to confuse you. This is the first initialization of the first bit plane, okay, where we take the bit plane and we just put the address. Then we take the same bit plane. He says notate, please note, okay. We take the same bit plane, but we do minus 80. And the reason why he could do minus 80, because before the definition in the section, so this is our bit plane definition, okay, for 80 by 256. Okay, one bit plane, that's all he defined. Okay, one bit plane. But he also defined plus 80 bytes, okay, before it, so that he can have that one line shifted up, and like that he creates that effect by shifting the bit plane one line up, if you want to call it like that. I hope that makes sense what is happening here. If you have issues or you do not understand, please comment. As I said, I see the comments immediately now, and when I make a mistake also normally. So I did the first example. Let's switch to the Amiga again. Because there's only one modification that I did. So what he did here, or yeah, what he did, because actually this was an idea from an example that he asked for us to try. Okay, what he did here is a bit different. So he loaded, I mean, I better get the book and show it on the book instead of explaining it here, because I might confuse you. So I'll show you on the code. So what I did, so remember the other one was minus 80, right? So what I did, I even added a pixel on the right, shifted it, so it shifted one line up, but I also shifted it by one pixel to the right. That's what I did. Let me see. Yeah, it is shifted by one pixel to the right. So if you see the letter, let's say L, okay, L or A, you can see that the letter A is shifted one pixel to the right. So basically I did that And yes, I added loading phase101.exe. So yeah. So I did that. Oh my god. By including, that's why I have including the shift register 1 1. Where is the shift register? So you know you have this shift register that shifts a screen by 1 pixel. Okay, so I shifted that by 1, and I did it on one of the Bitplanes. So that's one. That's why I have 10. Yeah, there you go. If I did this 1 1, okay, I would have shifted both Bitplanes. But like this, I shifted one Bitplane because we have two, and that gives the illusion that I have a font. I'm just going to show it like this to see what I mean first. Or 0 0 0 0 is as it was before. Okay, I'm just going to show it like this. Okay, so this is as it was before. Now I'm going to shift it 1 pixel to the right. So if we do 1 1, okay, nothing changes because we shifted both bit planes 1 1. Okay, but if we do 1 0, we shift one bit plane and not the other. So we shift the even bit plane and not the odd bit plane, and that creates that effect that there is a shadow, let's say, for each letter. Okay, that's all it is. And now we do the last example, 6F, where we will end, and we have an image with text on top of it. So the image, we know it is a 3-bit plane image. Okay, so I'm just going to explain it, and then I'm going to go to the book where we will end. So we have a 3-bit plane image, but we are adding another bit plane, which is the 4th bit plane, and to make the font in front of the image, okay, we make all the colors from 8 to 15 the same color. So like that, we don't get shades, we get all the same color, and it looks like that the font is in front of our image. Now we could have used dual playfield or things like that, but this is a trick to know. So basically the text comes to the front and is visible, like it's in the front of the screen. So I'm going to explain this. I think it's better we jump to the book. No, I'm going to jump to the book. I remember. So yeah, so let me see my notes. So as you can see, we have the first one actually. So we're setting the 3-bit planes. Okay, these are the 3-bit planes. The move quick 2 is from 0 to 2, which is 3. Okay, and we set the bit planes for that image that we have. But then we set a different bit plane which is the bit plane allocated using further down, using the BSS. Okay, so we allocated a memory and we take a note of that, and we set up bit plane 4, okay, to that pointer, basically to where it is allocated in memory. Then we print the usual routine that prints the screen to bit plane 4. Okay, so we print to bit plane 4, and notice that bit plane 4, all the colors, okay, this is the colors that he added because we added bit plane 4, okay, are the same. Okay, if we had these different, the image will not look like that. The font will not look in front of the image. It will just be a mix of colors, but like that we have imposed it, and we said that it has to be blue. And that's basically it. Thank you very much for following, and see you next week. Bye bye, guys. Bye.